Hello friends, welcome to the channel Electrical and Automation in English. So today's video is we are going to calculate how the LRV and URV values of the level transmitter, DP type level transmitter, how we can find it. I will explain with the simple calculation taking an example. I hope at the end of the video I will explain this video in a such way that you can definitely going to remember this calculation for the longer period of time. So moving to the next slide, I will tell you, let's take an example of one closed tank, a closed tank which is having a height of 110 centimeter as you can see on the figure. And I assume that its specific gravity is 0.9. And one thing I consider this, there is a transmitter which is installed in this LT tank, level transmitter, level tank, which is 50 inches below, or in terms of centimeter, you can say 127 centimeter is below. And LP side is wet filled. Wet filled means the LP side of this transmitter is filled with a kind of fluid which is having a specific gravity of 0.9. If the LP leg of any transmitter is filled with liquid, any kind of liquid whose specific gravity is known, then that type of calculation that we are doing, it is called wet lag DP type calculation we are doing it. So if we don't fill anything in that HP tapping, then it is the calculation become the dry lag and its calculation become different. Now we are assuming in most of the closed tank levels, closed tank system in our industries or anywhere you can see there is a wet lag system is very popular. That is why I am taking the example of wet lag. So the unit conversion is already you have seen. I converted all the units into the mm for the A's of the calculation so that you can understand very easily. So this is the calculation. Now at the end you can see there is a pressure. How we can calculate the pressure head of any tank? It is simple like that. Whatever the height of the fluid into the specific gravity of the fluid, we can get the head of the pressure of that head of the pressure of that particular tank. Now, how we can start the calculation? First, we have to start the calculation like that when the tank is empty and the level is showing at the transmitter is 0. So, how we can calculate level at 0? Still the transmitter is below to the tank. So, we are going to suppress this automatically. So, first we have to calculate in the transmitter. There were two tappings are there. One is the HP tapping, another is the LP tapping. In HP tapping, what is the total amount of head or pressure is bearing at that HP tapping? 0.9 is the specific gravity and 1270. In HP tapping, if the tank is 0, only the 120 centimeter, which is the amount of height which is below below the this tank, is the amount of pressure is going to be exerted by the pressure. So that height we have considered 0.9 into 1270 in millimeter water column, it will become 1143. At the LP side, all the you can see there is a condensate port. From that condensate port to the LP tapping, all the line is filled with fluid. So it is having the head of 120 centimeter plus the height of the tank which we have considered at 100% level, that is 110. And the specific gravity is same. So we are multiplying 0.9 with 1270 plus 0.91100. So the total LP value will come 2133 millimeter of water column. So for finding the delta P, what we have to do? For finding the delta P, what we have to do? HP minus LP. So we are minusing the HP minus LP value and we get the delta P of minus 990 millimeter column. So that means when we are using a heart and we having this kind of setup, then we have to give the value of LRVs minus 990 to the transmitter. When we give the value of LRV 990 millimeter water column to this transmitter, then the transmitter output will become 4 milliampere. It signifies that level of the tank is 0. So now we have calculated the value of 0% tank level. This is minus 990. Now we are moving to calculate the value at the tank level is full. That means what value we will get at 20 milliampere. So in the same way, we are what we calculated in the previous URV calculation, in the same way we are going to calculate the URV. So first we have to calculate the HP and LP tapping pressure head. So for the HP, when the tank is full, so the 127 centimeter plus 110 10 centimeters, the total head is applying the pressure as a pressure in the HP tapping. So the total value is 127 plus 110 into 0.9, it will become 2133. And same is for the LP tapping, because the LP tapping we already filled up with the 100% tank level. So the same amount of head is also acting on the LP tapping, that is 2133. And the formula for finding the delta P is HP minus LP. So it becomes 0. So the URV is become 0. And you observe that in most of the closed tank, URV is nearly 0 or minus, very low value of the minus. So this is, now we get the value of the LRV and the URV. You understand, this is a very simple method to find the LRV and URV value of any transmitter which is acting below, or if it is the transmitter is above the 0% level, then you can also minus that particular height. So you do not get confused that transmitter is below, transmitter is above. When you are calculating the head at LP and HP, that lower and upper side is get compensated, and you will get the exact dp what is actual acting. So the final transmitter configuration with the heart we can do with the transmitter is LRV minus 990 and URV 0 mmWC. So when the delta P or URV becomes 0, then the level shown by the transmitter is 100%. So the span is URV minus LRV. So 0 minus 990 is become 990. So it is ready for the hard configuration. You can fed this value, and by this way, I hope you understand this, how you can find the this value of this transmitter, range of LRV, URV and span. So maybe I will tell you something key engineering takeaways. Negative LRV. Most of the people think that LRV cannot be negative in a closed tank. So most of the time in the closed tank LRV is negative. You understand why? Because of the wet lag. Because at the 0% level, wet lag is always having some head, and that head will create the negative LRV. So wet lag causes a zero suppression. Yes, obviously wet lag, when the wet lag is present, the zero suppression is happen automatically. That is why I'm saying when the whether the transmitter is below the tank or upper the tank, it will automatically compensate when you exactly find the head acting on the HP tapping. And elevation effects is 0. Elevation effect is also bigger, but the span is remain same. So mmWC is the common for the Indian plant. That is why I have taken the reference of the calculation in all my calculation in mmWC. So I hope I have contributed something which you have learned today, and if you find it very grateful or it is knowledgeable, if something added to your knowledge, I will request you to like this video, share our channel and subscribe our channel, and also share with your technical groups, technical friends, so that the channel will grow faster as required. Thank you.